Okay, let me just mention a few things here. Uh, when you look at this one, there is no C in this line, and when you kind of factor out the common parts, you put the C in there. But my suggestion is this one looks like this is not equal, right? At least, so it's better to put C over here. And there is no one says this is the solid rule or method, right? So you can modify it for your own way. So my suggestion is, how about C at the end of this line whenever we hit zero or the repeated part happens. So students could see when you put all this crossover multiplication and arrange it, they could also put that C at the end at that moment, right? Then it's gonna be much easy, and without C is kind of wrong answer, right? So that's what I want to mention. And another one is, of course, this is just you show me how much you understand the whole tabular method, right? But for your actual presentation, I really suggest to show the integration by parts in regular way for more complicated equation, right? So show them uh, how the integration by parts is working, and like you don't mention it, but how long it takes, right? And how much is complicated, right? So after you show that, and of course, most importantly, you mention what really happens in there, and and after that, you just introduce this tabular method, and you can mention why you need the derivative of those part and integral parts of the other one, and why you have to matching like this, okay, crossover matching, right? Because of that regular method. So uh, I really wish you explain the relation between regular way to do it and this tabular method, right? What's the connection between these two? That might be more important. And when I listen your instruction, like yes, this method you mentioned, this one is simpler and faster and easier, but uh, I already mentioned that, right? Some faculties, some professors don't like to see just the methodology only, right? Without explaining any backgrounds or mathematical ideas, right? So uh, in your presentation, I want that you are not kind of passing or skipping the explanation of integration by parts. You, your your assumption is it's already done, right? And people, the students understand it. Okay, so but with this method, you can introduce this faster way to do that. And of course, later you mentioned that, right? So they have to know how to do that or something like that. But not only getting the derivative or integrals, but uh, the why this integration part by parts is working, right? Where does it come from? What's the idea behind it, right? So that part uh, must be kind of explained and empathizing that you are not missing that one, and you are not recommend this one over that regular method. No, the regular method is the first one, right? And they should have it. But if they got this much, it's kind of helpful for them to understand it and to remember that whole procedures, right? Something like that, right? So I want to get that much, right? And of course, it's I don't think in actual case you need to show all these different case then many times. You're not going to have then much time, and after you show just the simple ones, you might go to more complicated ones, right? Directly. Okay. So one thing I want to do is how about make some kind of rules out of these basic kind of expressions, right? The, like a polynomial, a trigonometry, exponential, log, maybe square root, right? The radical forms. So among these, if they are combined, they are presented as a product of any of these two, then which one has kind of most likely to become this portion, right? So like this, right? If the polynomial comes with any others, yes, this is the choice. But if the log comes, then log is the one should be here, right? Because certain reason. So please try to find out that and giving that kind of suggestion, right, to your students, right, like that. So just look at the given integrals and product of two expression, and if one is log, then that should be here first, and the other one should be over there. And another thing is, actually, tabular method is not only good for getting the result, but also it's good for checking method whether that kind of separation is good enough, okay, to apply this uh, integration by parts, right? So I'd rather empathize that part, right? So arranging by this way, students could realize it goes to 0. Then, yes, the other one doesn't matter what, you get it, right? Only problem comes with log, right? If you put the polynomial here and the log over there, then yeah, it's almost kind of impossible to get the entire derivative of it, right? Then it's better to put that log over here like that, right? So, uh, and the reason is it's easy to get 0 there, okay? So the reason for uh, having this tabular method, actually there are two folds, right? One is it's good tools for checking whether the integration by parts is going to work or not, and which one is going to be this side, which one is going to be that side, okay? That's the, and second part is, yes, it giving us really fast, kind of getting the result really fast, right? So once again, your assumption should be like you're going to teach the regular integration by parts method to your students and let them have enough practice on it, but at the end you just introduce this method, so let them figure out which way is whether the integration by parts is going to be applicable or not, and this one gives fast result. And second suggestion is, please make sure you make some kind of rules among these expressions, right? So whenever log is involved, log must be here. But if it's not, then next choice would be the polynomial and maybe exponential and trigonometry, that kind of routine stuff, right? So that's looking for. And here, once again, right, you don't put C anywhere, and suddenly at the end you just put C there, right? So that is not no math involved, right? Because just the result should have C, and that's the only reason right there, right? But if you make some kind of rules over here, right? So in this case, you don't go back to 0 here, but it's like it's just repeat. So, and sine, cosine is also repeat. So both of them are kind of repeat, okay, or keeping the original formats here. So then this is the moment they have to stop. Whenever it's stop, then put C there. And when they do these products, just put that C at there. Of course, in this case, even that C shouldn't be here, but I mean, you can just make a rule over there, but definitely not at the end, right? Put that C here. Right? So okay, so that's what I thought, right? So about three cases why putting C, sorry, and so there are three things, right? Handling the C at the end, right? Make a kind of rule for that, and make a kind of rule among the expressions, which one is going to be the most likely to become the left column parts, right? Like that, some types of rule. And third one is what is that? The yeah, the uh, try to give the integral by parts first in regular way, and showing this explain this tabular method and emphasizing two things. Good for checking which one is which, right? Which one goes to first, second, like that. And second, it gives us the fast result. Okay? So emphasizing those two. So let's say your goal, the goal of your research, your project is you deliver a method, this tabular method, which is good for two things. First, students could figure out, okay, which way they do for integration by parts, right? Using this way. So even they don't use this one is just good for checking that part, right? But this one also gives them the fast result, right? So that's the kind of your goal, right? That's what you want to show. Okay? Let's say that. And still, you haven't covered that whether we could extend this one to the product of uh, three expressions, right? So not only one type of integration by parts, but when you do this, maybe this one is still product of two different expressions, so you have to apply integration by parts again, okay, separately for here, right? Then can it do it, right, with this just and one snap, right, with this method? So please thinking about that one. So hopefully by end of next week, please give me any kind of result about these four questions, right? So then that's good. I mean, this is really a good way to prepare it, right? So yeah, you're almost done, right? So just to try to kind of practice with that, and hope so next one I'm gonna expect really good one, right? I mean, this is really good, but like adding some this and modifying a little bit. Okay, good. Thank you. See you.